I have no idea. So instead of me trying to write this out a bunch of times, we can use a loop. We can say, run the same code for every individual teacher. So instead of saying this is the guy in first, put a variable in there. Let a variable keep track of which number we want to test. Just like we did here. This is going to be a variable response. It's going to take a random number, modulus 5. It's going to be different every time. We can write a for loop to do it to every single member. For int I equals 0, I is less than teacher roster size, I plus plus. So depending on the size of our teacher roster, go to every single one, starting with 0, ending with whatever's last, give it a random name. Understanding why for loops are awesome?
Yeah.
No matter how many teachers I end up with, I only need to say this once. Because the loop is going to execute this multiple times for me. So I'll say, assign the name, and I'll say immediately print it out. Immediately print out the name you just assigned. This is not really what the assignment needs to be. I just want us to take a look at it. And I'll say return line. Then, so it looks like I had a lot of features, maybe towards the maximum. There's not really a lot of names supported yet, so we see a lot of repeats. They're all there. I'll run it again. We'll get a different size list with different names. Short list this time. If we run it 50 times, we might get, in one of those cases, a list of size 1. Or sorry, 5 is our shortest. 1, 2, 3, 4, 5, 6, 12, 11, 13. Everyone understand why I'm having a different size list? Why the names are always randomly associated? 1, 2, 3, 4, 5, 6, 7, 8. That's pretty close. It's one of our shorter lists. Later we could assign more names to this. If I wanted to be really good about this, I'm going to make a quick improvement on my name list. Because if I added more names to this list, I have to change this number, correct?
Yeah.
Because it says I'm a list of 5. If I add more to this, I'd have to say you're actually a list of 6, or 7, or 8. And down here where it says random modulus 5, I have to change that to an 8. I don't like whenever you have to change constants in more than one place. That's bad code. Let's make a quick improvement. Make a constant int feature name size, and the same for this name size. Let's say equals 5 equals 5. This way, if I ever change the list sizes, I don't have to write it out in multiple places. Does everyone understand that change?
Mm-hmm.
Anytime you can minimize the actual assignment amount, right? You can use variables in more places. You have code that is called extensible. The idea is someone could easily come in and make modifications, and they wouldn't have to change it in multiple places. They would just up the number, add a name. Add a name. Let's add a couple names real quick. Do Professor Lovegood. Professor Bonsai. Those are their classic teacher names. Well, I know what I don't have. The drizzle. There we go. So I added 1, 2, 3 names. We'll put 5 to 8. We'll turn this to 8. Cool. We've got a little off task, but this is good to go over. where were we? So we have a list of teachers. It's all working fine, everything's great, everything's dandy. But now, what does every teacher need?
Great.
Every teacher needs a name, a roster, and a roster size. So I'll sign those things. I'll get rid of my print statement. I don't need to read the names right now. They got a random name. They need a random roster size. Let's say between 15 and 30 students in every class. So that's a variable of 15, something like that. Close enough. Now I have to initialize the list. You see how for doing the student list that every teacher is storing, it's the same as doing the teacher list. It's just a list inside of a list. So we say, grab that teacher, grab the teacher's student roster for that specific teacher. The new list of students and the list blank. See, that's the teacher, not roster size, the one we just assigned right above. Okay, all this stuff right here is matching what we just did. Random size, new array of that size. For loop. Random size, new array of that size. What comes next? A for loop. The same as the outside, but it is on the inside. What should I name this int? Any name will do. As long as I don't use any names I've already used. I tend to go in alphabetical order starting with I. So last one is I, now I'll do J. J is less than what?
Roster size.
The roster size. Whose roster size?
Teacher's roster size.
The teacher's roster size. What's teacher?
Teacher I.
Teacher I. Because whatever count we're on, that's the one we're working with right now. So I would say, teacher roster, I, dot, roster size. I plus, sorry, J plus 1. Now we're here, we're dealing with students. What does a student store?
Name and grade.
Name and grade. We'll do the same thing. We'll say, get a random name, get a random grade. All right, teacher roster of I, got student roster of J, dot name, is random, modulus what?
Modulus.
The same thing we did up here, a little different.
So 15, what's 15?
In fact, now that I'm looking up here, I totally left out the more important line. Student names, you have to put in this line. So some random number, modulus what?
Modulus 15.
Student name size. This is getting student names. This line and this line are nearly identical. But for every part that says teacher, we have students. Right? We have two arrays. One for teacher names, one for student names. The length of the teacher names is teacher name size. The length of the student names list is student name size. So I want to name a student. I say your name is equal to a random value of student names. And take that random value modulus student name size. Make sure you always get a random value that isn't greater than that actual list size. What else do students need?
Grade.
The grade. So the teacher roster of I, dot roster for J, that gives me access to students, not grade. What possible grades can you have?
A, B, C, D, or F.
We're doing percent grades.
Oh, 0 to 100.
0 to 100, random. modulus 101. That is the end of assigning values. Does anyone lost? Does anyone understand why I have to write when I write dot, when I write the question? Yes.
I'm still not quite sure about the modulus. Why is it 101 now?
Because we're,
If I did modulus 100, right, I want grades to go from 0 to 100. So whenever you're doing modulus, 0 will always be a possibility. You'll get a 0 if it's an even division. 3 modulus 3 will return what?
3. No, it will return 0.
It will return 0. It'll say I tried to divide 3 by 3. It worked out evenly, and I have no remainder. 4 modulus 3 will give me what?
1.
1. It'll say I tried to divide 4 by 3. If 3 went into it one time, but I was left over with a remainder of 1. So if I want a range of grades 0 to 100, if I said modulus 100, it's actually an end on 100, I would get a 0. Modulus 100 will give me from 0 to 99, which is 100 values. Okay, so what you're modulusing by is how many numbers, and then the offset decides where that number starts from. If we count to 3 starting at 0, we have 4 numbers. 0, 1, 2, 3. So when you do modulus of 4, you'll get those 4 numbers, 0 to 3. If I want 0 to 100, I have to do modulus of 100 and 1. So I'll give percentile grades from 0 to 100. So again, that's the end of assigning values. I could add more names later. But now we're ready to actually tackle the question of who's got the grade, has the best grade. Does everyone understand structure? Does this help?
Help a lot.
This is just defining, this is a blueprint. Defining the data type. When you want to use this data type, data type name. In this case, we want an array. Well, it's the same way we use arrays in every assignment we've done. It's a different data type. A custom data type instead of a primitive data type. We did like the random stuff against the teachers, against the students. And now we want to know who had, what was it again? I'm checking the, it was best student ever, right? Find just the best student, and then find the teacher with the best average grade. How do we find the best student?
Then they have to like do a high grade.
Yeah, but tell me in different terms. Sometimes I want you guys to tell me in code, other times I want you to tell me in logic.
We need to make a, we need to initialize.
No, don't tell me in code, just tell me in logic. What do we need? Like, you were going to give me a variable name, but I wanted to know what it does, not what data type. Just, what do we need to keep track of?
The number. It's the grade number.
All the grades of the student.
We need to find who has the highest grade ever. So we need to store what the highest grade we found. Just as we've done all this sorting and comparing in the past.
So when we did oldest person in the birthday calculator.
Mm-hmm.
Okay.
Now, last time we did that kind of stuff, what's usually our starting value for highest grade or lowest number, whatever we're trying to search for? What do we usually start that
First thing
value
we
with?
encounter.
It's usually the first thing we encounter. Why do we not need to do that this time? That's not the reason why? Any ideas of why we don't need to grab an initial grade and start comparing? I mean, we need some initial value, but it doesn't need to be one that exists. What's the lowest possible grade?
0.
So as soon as we find something higher than a 0, we can move forward. We don't need to grab the first teacher's first student. We can just say, as soon as we find a grade higher than 0, let's keep going. So our highest grade should be... I might go over that again. A lot of people...
The highest grade is...
So we do need to keep track of what the highest grade we've ever found is.
I mean, highest grade is greater than or equal to 0.
Oh, we'll get to that in a second. So we need to track the highest grade we've ever found, and what else do we need to track? We need to track track who had that highest grade. So I'll make.
That's what I didn't get in my code, the name part, to access the name of the student.
Let's make first what the highest grade should be. Grades are what data type in my program?
Float.
Float. So my highest grade should probably be the same data type. Float, highest grade, I'll say equals 0. I can't remember if it's me for an F or not, always. I'll say highest grade is 0. And that's what I'm going to make all my first comparisons to. If someone has a higher grade than 0, they will become the new highest grade. So highest grade is 0. All right, I need to store who has the highest grade. Now, let me make sure what I said. Find the student's best grade. Okay, I didn't explicitly say what you had to print out. Let's say you print out the student's name and their teacher. If I was just their name, I could just make a string, highest grade name. That'd be okay. I could store the entire student. But I want a little more than that. I also want the teacher. I want to say the best grade was in this student's class by Bill Johnson with an 85 or whatever. So I'll need to know who their teacher is and who they are. Actually, I'll just store both. I'll say, yeah, student, highest grade, underscore, student, and teacher, highest grade, underscore, teacher. Something. Now, we can do this in a new for loop. We could also do this as we're assigning values. The reason why I don't like to do that, even though it's more efficient, is because presumably someone might actually give you all this information instead of you randomly creating it. Let's make a new for loop. I can use int I again because the scope of this I ended right here. Just like the scope of j ended. I need to go through all the teachers. All the students. Comments just to clean this up a bit. Generate.
I see you do that with all code. Is that what most programmers do to separate things, or?
This is a common thing that we do. What they'll do, even further than this, is they'll actually extend this onto a couple lines. Usually looks like this. In the middle, they'll put what this program, like what this part of the code should do. Times the highest grade, like comparing yada yada yada.
Huh.
And you'll see stuff like this all the time. I'm doing the short version. But if you're working on this big project and with a lot of people, excellent commenting is essential. Okay, this is what we've done so far. We have two structures. The student just stores the name and grade. The teacher has a name, a list of students, right, a pointer to a list of students, and how big that list is. Our main function is keeping track of some random names we can use. It's going to keep track of who the highest grade is, or what the highest grade is, who earned it, and which teacher or which class he was in. We also have a list of all teachers of some size. We randomly assign our possibility of teacher sizes. We said 5 to 50 teachers. We create that array. Initialize the array and we know how long it's going to be. So this was Modulus assigning random values. We went through every teacher. We gave them a name, a roster size, and a roster of that size. Then for every student in that list, for every student in the teacher roster, going down to that teacher's roster of students, giving every student a name and a grade. This is the basic hierarchy to any kind of object-oriented design, any kind of big project. You're going to break stuff down into structures. Then you're going to have structures storing structures. You're going to have arrays of structures storing arrays of other structures. Endlessly going for as long as you want. Outside of this, we might have a list of schools and departments and individual classes, and we can turn this into a huge database project, and it wouldn't be terribly exciting, but these lists, these names are going longer and longer. Have to say, like district, school, department, teacher, student, grade. But understand that there is no limit to how many levels you can go in. Right, I could easily just come back up here, and I could say, this part don't copy. I would say struct department. And the department would have maybe a department name, and then a list of teachers. Then every department could actually be stored in the school. And the school might have a name and a list of departments. Did you notice in this example how I named all of my list roster?
Yeah.
Am I going to run into any problems with that?
Yeah.
Why?
We already have roster. We have roster declared in like 3 structs now.
But the scope of this roster only exists for teacher.
So how would it know the difference between the rosters, though?
Because we put like teacher dot department dot name.
I'm going to know which one I'm talking about because they're owned by different people. I have to start with, let's say I make a school. Did I call it a school? Yeah. A school. My school. Not a very exciting name. I can say my school dot roster. That says, a roster of departments, a list of departments. And assuming it has some information, let's keep going. Let's give it a quick, let's do the department list. Say it's the 3 departments. I can say my school 0 dot. Department roster school. Oh, that's what that means. My school dot roster equals department 3. My apologies.
That right there was giving me trouble last night.
I don't want to change anything about my school. It was the array in that I wanted to initialize. Roster's that array. Now I can say my school roster 0 dot. No, before. Roster 0. Department. Anyway, because I have an arrow, we double check my arrows.